Hello everyone and welcome back to a new video in programming the finite element method using MATLAB. In this video we are going to continue our efforts in solving the linear elastic problem, and we are going to tackle something called initialize analysis systems. Let me give you very quickly a reminder of the general picture. We are at perform linear elastic analysis, and to achieve that there are multiple steps I need to do. We are on step 4, solve linear elastic, and to solve the linear elastic problem we need to achieve those sub-steps. We're still in step number 1. So we're going to see what kind of systems that need to be initialized. We're going to add some properties to the controller, and we're going to have some fun. This might not be a long video, which is a good thing for a change. And as per usual, I want to remind you of the 3 reminders. First of all, it's part of the FEM series that will be linked top right. There is another playlist that includes only programming stuff, also linked. And finally, my dear channel members would have access to the entire source code. However, if you are not a channel member, then don't worry, because in the end, every single line of code is written in front of you. You can write along with me and you'll have the exact same code as me. You just need some little effort. So yeah, with that being said, and without further ado, sit back, relax, and enjoy the show. So, what are exactly the systems I need to initialize? Well, there are basically some storage systems. That's what I mean by initializing systems. We need to initialize storage system because MATLAB hates reallocating matrices. There are some cases where I cannot escape from that, but typically, if I can escape, I will. Now here, for the properties, we need to add some extra properties. I might do regions for the properties. I don't know, maybe I should call them str and fem. I'll just leave it for now. Maybe not organized, but whatever. Let me first go here and add me some properties that the controller must have. The controller must know the global stiffness matrix, the stiffness matrix of the structure. So global stiff, let's put an enter key here just to separate. Global stiffness matrix. You should start getting excited because you are starting to tap into the domain of the finite element analysis. Also, we would have the global load matrix, and something called the equivalent nodal forces. Oh my, this is a very hard thing. The equivalent nodal forces and the global displacement matrix. So if you remember my work in the Dalil and Logan series, there was something about F, I think minus or plus E and L equals Kx. I forgot if it's plus or minus depending on your signs, but you can see all those, this E and L stands for equivalent nodal force or load. I should call it load, by the way, not force. It's more accurate. Let's call it loads. Now those 4 players in the equation of the FEM is exactly what you see here. Now those need to be initialized. So let's initialize them. Okay, how do I initialize them? This is where I need to explain to you the sizes of those things. The global stiffness matrix basically is going to be basically a square matrix with sizes of 6 times the number of finite element nodes. Because I have 6 degrees of freedom, and let's say I have an n number of FEM nodes, each node has 6 degrees of freedom. So if I have, for example, 4 nodes, then this would create a 24 by 24 global stiffness matrix. What about the global load matrix? The global load matrix is going to be a matrix, not a vector. I know that you are used in the finite element method to see a vector for the loads. However, in my implementation, we're going to see a matrix. But why is that? The reason why this is because we have str load cases. Remember, we have some load cases, which means I need to solve the problem over and over and over again for each individual load case. Now, to kind of make it easier for the entire solution, I will have a matrix of the loads where the rows are going to be the degrees of freedom and the columns are going to be the load cases. You could have a separate column for the dead load, separate column for the live load, and so on. What about the equivalent nodal forces then, or loads? Now I'm giving a prediction. I will blunder the name of it somewhere. I will call it equivalent nodal force somewhere, and I will get an error in MATLAB telling me that it's called nodal loads. That's my prediction. But still the question stands. What about the equivalent nodal loads? The equivalent nodal loads are going to have the same size as in the global load matrix, because it would have, once again, for each degree of freedom and for each load case. The global displacement matrix is the same. Because I'm going to solve for different load cases, I need, for the global displacement matrix, the degrees of freedom in rows, and for every single load case, there is going to be a column that stores the solution of that load case. So that's my game plan. And let's define those things. So in the initialized systems, which is here, I'm going to first of all declare DOF to be 6. I think I should make it constant somewhere, but for now, I'm just kind of too lazy. Then I must get the number of nodes, basically. I can basically do this by saying here, maximum node serial number. Let's call it serial number. This equals the object.fem nodes. Wait, it's not fem nodes, it's length. The length of the object.fem nodes is going to be the maximum node serial number. Or I could just call the serial number. Then here I would need to find the load case number. And this is going to be the length of the object.load cases, right? Is it called load cases? Yes. So this is the initialization of, this is some helper values to help me initialize the systems. So now I'll just copy those 4 things. I'll copy them, go down to the init. Wait, I think I misplaced it. What a noob error. Let me just Ctrl X this. Why was I even putting it here? I was here. What gives? Okay, so global service matrix, let's initialize it. So we said the global service matrix is going to be zeros, equals zeros. And this basically opens a matrix that has zeros in it. And it's going to be DOF multiplied by max node serial number and DOF multiplied by max node serial number, because it is a rectangular matrix. So that's how we're going to do it. What about the global load matrix? Well, it's going to be zeros equals zeros. I keep forgetting the equals for some reason. And it is going to be DOF multiplied by maximum node SN. I just saw something cool. Is it really using some AI here to predict load case number? Kind of interesting, to be honest. Okay, for the equivalent nodal forces, I have 2 options. I could go fancy schmancy and just say this equals global load matrix, and don't worry, we are just equalizing the value, not the reference. Or I could just copy this and paste it again. Up to you if you want to go fancy schmancy or just want to be solid like me. It depends on your programming style. This is the initialization of the 4 systems. However, we're not finished, because remember what I said, there will be storage of the displacements. So I better initialize the displacements. Now, maybe I should initialize displacements. Maybe I shouldn't, to be honest. I'm really split about this, because we are not in C#, so you don't need to init stuff. You can just assign it directly. I kind of want to init it, because why not? It kind of looks nice. So here I'll go for a loop for I equals from 1 to the length of the object dot str nodes. And I'm going to run another loop for I equals for 1 to the length of the object.fem nodes, because they both have the right to store the deflections. So here, I will first of all fish out my target, which is going to be object, I should say target node, which is going to be object.str nodes of I. And here I'm going to go for the target node dot deflections, and I'm going to init the deflections. So how can I initialize the deflections? Load case number and degree of freedom. Okay, let's mix it up. And also I need to copy this entire thing and change it down there and paste it here, basically. Of course, this becomes target fem node. I'm just going to copy and paste it here. We're going to search the fem nodes, and we're going to define it. Now here I must quickly check if this exists. There are 2 ways of checking. I either go and check, or I just check if there's an error. So let's run. If there is see, there is an error. Why? Because it doesn't exist in the str nodes. Fantastic. So I go to my str node. I think it's here. There we go. I'll open the str node. Here I'm gonna go and say deflections. And that's the only thing I need to do. Let's run it again, and it's not running. That's a surprise. Really? I didn't even put deflections for the fem node. What a shame. Okay, so let's go to the fem node, and here, it's called deflection. It should be deflections with an S. Wow, just an S missing. Let's run again, and it's working. Fantastic. So I think we have accomplished our objective by initializing the systems. So that's yet again another, wait, there's an error? Okay, I haven't achieved anything because this is not just global, it's the object.global. That is a mistake. Otherwise, it doesn't initialize anything. So yeah, I think we have reached another milestone. We finished one of those steps necessary to perform the analysis, namely the initialize. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a initialized sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support to the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.